Hello everyone, today we'll be going over section 3.3, adding and subtracting using fraction notation. So last time we did adding and subtracting decimals, this time we're going to do fractions. Okay, so before we do that, we need to know two things first. The first one is converting from mixed fraction to an improper fraction, and the next one is the reverse, converting from improper fractions to mixed fractions. Okay, so there are a few steps for each one of them. To convert from mixed fractions to improper fractions, you're gonna multiply the whole number by the denominator. So multiply the number in front by the denominator, and then you will add the product to the numerator. And we've learned that products are the answers to a multiplication. Right? So you're gonna add the number. You're gonna add the answer to the multiplication from the first step to the numerator, and then the denominator stays the same. The next one is converting from improper to mixed fractions. So you're gonna do a division. You're gonna divide the numerator by the denominator, and then the quotient is the whole number, and the remainder is the numerator. And then denominator stays the same, so you keep the denominator. Okay, so let's do one example together. Let's say if I have 21 over 5. To change that to a mixed fraction, you're going to divide 21 by 5. So 4 of the 5s will go into 21, so the remainder is 1. And so the quotient is a 4. The quotient is the answer to division, and then the remainder is 1. So it says quotient is the whole number, so that will be 4. Denominator stays the same, denominator is 5, and then the remainder is the numerator, so that's 1. So then basically this is 1, this is the 4, and so quotient, the whole number, remainder, the numerator, and denominator does not change. Okay? So let's try some examples together. Okay. The first one is to convert from a mixed fraction to a improper fraction. Well, we know we're going to multiply the whole number by the denominator. Well, negative stays as negative, don't change that. So we're going to multiply the whole number by the denominator, so 3 times 6. And then you add the product to the numerator. So you add this to the numerator, the 5, and then you're going to keep the denominator. So keep the 6. And so the answer then will be 3 times 6 is 18 plus 5 is 23. So 23 over 6 will be your answer. Okay. So you are going to multiply these two, 3 by 6, and then you're going to add the product to the 5. So multiply and then add, and denominator stays the same, so keep that denominator. Okay. And the next one, converting from a improper fraction to a mixed number. So improper fraction, we know it's when the numerator, the top number, is greater than the bottom number. So we're going to change that by dividing. So 17 divided by 4. 4 times 4 is 16. We're left with 1. So then this part will be our whole number. So that's 4. And then the denominator is 4, it doesn't change. And then this 1, the remainder, will become our numerator here. Okay, so that's how to convert. And next, what we're going to do is we're going to learn how to find common denominator. Lowest common denominator is also called LCD. And finding the LCD is the same as finding the LCM, the lowest common multiple of the denominators. Okay, so let's see what lowest or least common multiple means. Least common multiple of two numbers is the smallest number that is a multiple of each number. And next definition is prime numbers. A prime number is a number that's only divisible by 1 and itself. So 1 and itself. And that these two numbers, 1 and itself, are two distinct numbers. Which means that they are not the same. So 1 and itself has to be two different numbers, not the same number. And so 1 would not be a prime number because 1 is only divisible by 1. Although itself is also 1, and 1 and itself still 1, they're not two distinct numbers. They're just the same number. They're one number. So 1 is not a prime number. Okay, so the way we use to find, there are multiple ways to find LCM. By definition, we know LCM between two numbers are the smallest number that each number goes into, or the smallest multiple that each number goes into. So using that definition, we can just find the multiple of each of them and then see which one is in common. So let's say, let's start with the bigger number. 49 is a multiple of 49. 49 times 1 is 49. And then 49 times 2, 98. And then times 3, 147, etc. And then let's use 21. 21, the first number, 21 times 2 is 42. And then times 3 is 63. Times 4 is 84. Times 5 is 105. Times 6 is 126. Times 7 is 147. Well, now you see that 147 and 147 are the multiples, is a multiple that both of these numbers go into. So the lowest common multiple then between the two numbers will be 147. This method is okay with smaller numbers, but then with bigger numbers, it's very hard to find all the multiples, especially if you have more numbers. Let's say if you have 3 numbers that you're trying to find the lowest common multiple of. Okay, so that's one method. And another method is to use prime factorization. So this is to find all prime factors of each number. Let's do that. We can do that using a factor tree. I know 21 is 3 times 7. 49 is 7 times 7. So 21 is equal to 3 times 7. 49 is equal to 7 squared. I'm gonna line the 7s up. Okay, so the LCM is equal to the product of each and every number and the greatest number of them. So if you look at the 3, we only have 1 3 here, and so because we need each of every number, so we need 3, and that 3 is the greatest number that it can be. So 3 is just 3. And then we can look at 7. We have 7s for each of the 21 and 49. And the first 7 is just 7, but the second 7 is 7 squared, which is 49. And which one's bigger? Well, of course, 7 squared is going to be bigger. So we're going to take the bigger number, 7 squared. So we're going to take the 3 because there's only one 3. And we're going to take the 7 squared because 7 squared is the bigger number. And so then your least common multiple is going to be 3 times 49, which is 147. Same as the method you used to, same as the previous method. Okay. Now the next one we're gonna do is 84 and 54. So I'm not gonna find all the multiples of each now. I'm just gonna use the prime factorization. You guys will see why. So 84 is divisible by 4 and 20. So 84 is 4 times 21. 4 is 2 times 2. 21 is 3 times 7. And then 54 is 2 times 27. 27 is 3 times 9. 9 is 3 times 3. So then we have 84 is 2 squared times 3 times 7. So that's a prime factorization of 84. And then 54 is equal to 2 times 3 cubed. We have 3 3's, right? 3 cubed. And so now we're gonna, let me write that down maybe. We're gonna take one of each number, and the number we're gonna take is the greatest number. Greatest number of them. So let's look at this. Well, each number. So we're going to look at 2's, 3's, and 7's. So for the 2's, 2 squares and 2, which one's bigger? Well, of course, 2 squared is bigger. So we're going to take this one. And then for the 3's, we have 3 and 3 cubed. Which one's bigger? Well, 3 cubed is going to be bigger. And then 7, well, because we only have one 7, so that's the one we're going to take. And so the lowest common multiple is going to be 2 squared times 3 cubed times 7, which is 4 times 3 cubed is 27 times 7. If you multiply these all together, it's going to be 756. So the lowest common multiple here is 756, and that's why I didn't find all the multiples of them, because it's going to be a lot of numbers to write. Okay, so using the first method is okay with smaller numbers, but if you have bigger numbers like these, just use the prime factorization. It will save you a lot of time. Okay, and then so let's move on. Question 3, example number 3 is to add or subtract fractions. And whenever you're working with fractions, you will need to always simplify them if possible. Okay, so to add or subtract fractions, we know that they will have to be in the same denominator form, right? They will have to have same denominator. So to do that, we need to find the lowest common denominator. And so the lowest common denominator for part A will be just 6. Whenever you have two consecutive numbers, like 2, 3, 4, 5, 6, 7, the lowest common multiple between them is always going to be these two multiplied. And 2 times 3, 6, or 4 times 5, 20, like that. Okay, so now that I know the lowest common denominator is 6, so I'll change them all to denominator 6. So what do I need to do to change that to change the 2 to 6? I'll need to multiply by 3, right? So whatever I do to the denominator, I'll have to do the same thing to the numerator. So do 3. So 3 times 1 is 3, and then this side I'll multiply by 2. 2 times 3 is 6. 1 times 2 is 2. So I have 3 over 6 minus 2 over 6. Now that I have the same denominators, I just need to subtract the numerators. So keep the denominator and then subtract the numerators. 3 minus 2 is 1. Okay. All right. Next example, question B. Question B, the denominators are 12 and 8. They are different denominators. So to have the same denominators, we'll need to find the lowest common denominator. So I know 12 is equal to 4 times 3, which is 2 squared times 3. If you guys can't do this directly, you can always draw a factor tree. And then 8 I know is 2 cubed. So now the lowest common multiple between 12 and 8 is going to be, let's just use lowest common denominator. Between 8 and 12 is 2 cubed times by 3. So that's 8 times by 3, which is 24. Okay, so I need to change these two fractions to over 24. So 12 times by 2, so I need to multiply the 2 to the top. 8 times by 3, and then multiply by 3 as well on top. So that's 10 and 21. So 10 plus 21 is 31. So 31 over 24 will be our final answer. Okay, moving on. Now that we have 3 fractions together, we change everything to a common denominator. And so let's do it. 8 is equal to 2 cubed. 12 is equal to, well, we have that already over that side. 12 is equal to 2 squared times by 3. And then 15 is equal to 3 times 5. 3 times by 5. And so from each column, we're going to take the highest of them. So the highest will be 2 cubed for the 2's, and then 3 doesn't matter. They're both 3 to the power of 1. And then 5. So the lowest common denominator here will be 2 cubed times by 3 times by 5, which is 8 times by 3 times by 5. So 24 times 5 is 120. And so we'll need to change of the 3 fractions to over 120. Well, 8 times by 15 is equal to 120. 12 times by 10 is equal to 120. 15 times by 8 is equal to 120. So 15 times by 3 is 45. 7 times 10 is 70. 8 times 11 is 88. Okay. So then, because the denominators are all the same, we can just combine the numerators. So that's 45 minus 70 plus 88. And so all together over 120, the denominator doesn't change. And so that will equal to 63 over 120. And so notice how both 63 and 120 are divisible by 3. So we're going to divide both the top and bottom by 3 to simplify them. And so that will give me 21 over 40. Okay, last example. This time all of the 3 fractions are mixed numbers. So to do this, let's just change all of them to improper first. you're gonna multiply them and then add, multiply, add. So 3 times 6 plus 2, 18 plus 2 is 20, minus 5 times 7 is 35, plus 3 is 38, plus negative 4 times 3 is 12, plus 1 is 13. And now 3, 4, and 5. These three has a common multiple of 60. You guys can do your you guys can do your factor tree and to find the lowest common denominator, but I know it's 60, so I'm just gonna save some time here. I'll change all of them to 60s. So then multiply by 20. This one multiply by 14. The last one multiply by 15. So I'm gonna get 400, 456, and 195. So now all of them have the same denominators. We can combine them. So that would be negative 400 minus 456 plus minus is just minus plus a negative, so minus 195. And so all of these together will be negative 1051. You can do your calculation aside. So that would be 1051 over 60. And so now let's move on to two word problems. The first word problem says two packages that weigh 1.5 pound and 3 3/4 pound have the same total weight. Well, here, same means they are equal. Same total weight as 1.25 pound package plus another package of unknown weight. Well, so what it's saying is that this one plus this one, because and means plus, right? So let me just, and then here you also have a plus, so what it means is, oops, the two numbers together, the first number plus the second number, will equal to same total weight. Same means equal. Will equal to 4.25 pound package plus I know just means plus another package of unknown weight. So basically, this one plus this one is equal to this one plus something you don't know. Well, I can write an equation for this. So basically, 1.5 plus 3 3/4 is going to equal to 4.25 plus something else. I don't know. So if I use x to represent the unknown weight, I'll need to declare that variable. I'll need to say, oh, let x equal to the weight of the unknown package. So always, when you guys are using a variable, you need to declare the what the variable represent. Okay. Okay. We can do our algebra, but before we do anything, since it's adding and subtracting fractions, we need to change them to improper fractions first. So 1.5 is 2 on the denominator, and 1 times 2 plus 1 is 3 plus 3 times 4 is 12 plus 3 is 15. Change that one as well. 4 times 4 is 16 plus 1 is 17 plus x. Okay, so since we have an equation, you guys, when you solve for equations, you need to do it vertically down. Okay, so you need to make sense vertically down. Okay, so you want to simplify each side first. So these two numbers can be simplified. You can add them together. And the common denominator is 4, so you need to multiply this one by 2 over 2. Now 2 times 3 is 6. 2 times 2 is 4, so 4 times 6, 6 over 4 plus 15 over 4 is equal to 17 over 4 plus x. And so if you combine the left-hand side, you get 21 over 4 equals to 17 over 4 plus x. And so I know to find what x is, to find what the weight of the unknown package is, I need to isolate the x. So to isolate x, I need to get rid of this thing. I need to get rid of the 17 over 4. And so what I can do is I can just subtract both sides by 17 over 4. Because positive 17 over 4 minus 17 over 4, these two will cancel each other. So I'll subtract on the other side as well because it's a equation. So these two will cancel. And 21 over 4 minus 17 over 4, if you can't do this directly, you can do it aside. The denominator is the same already, so you can just subtract the numerators. So that's equal to 21 minus 7 is 4. 4 over 4 is 4 over 4 is what? It's just 1, right? So your answer will be 1. And the side we have these two cancel, so I have positive x. Positive x is just x. So I have x equal to 1. And after you've done that, you need to write a conclusion statement. So you say that the other package weigh 1 pound. Okay, and so moving on. Next example says Paul is 7 3/4 centimeters tall and taller than his dad. And if Paul is 1.9 meters tall, how tall is his dad? Well, this seems like it's abstract. If you guys want, you can always draw a picture or diagram to represent the situation. So let me draw. So this is Paul. And this is his dad. So this is Paul, this is his dad. And we know that he is 3 3/4 centimeters taller than his dad. So what it means is that the height between he and his dad is 7 3/4 centimeters. And so it tells you that Paul is 1.9 meters and it's asking for his dad. Well, Paul is that tall, and he and his dad has a difference of 7 3/4. So if I just use Paul's height minus this distance between the two, I'll get his dad's height, right? So I can just subtract. I know his dad's height is equal to Paul's height. minus the difference. So that, I don't know what it is, but Paul, I know it's 1.9 meters, and the difference is 7 and 3/4 centimeters. Okay, but notice how meters and centimeters are in different units. So if they are in different units, you can't really add or subtract them, right? So you have to change them all to the same unit. Well, I know that 1 meter is equal to 100 centimeter. So 1.9 meters then will of course equal to 190 cm. So I can change 1.9 meters to 190 centimeters, and so minus 7.3/4 centimeters will equal to his dad's height. So because I'm subtracting by a fraction, I'll need to change that fraction to a improper fraction. So 190 centimeter, we can do 190/1, and then minus 4 times 7 is 28, plus 3 is 31. So I have 190/1 minus 31/4. And so to subtract fractions, I know they will have to have common denominators, so 4. So multiply both top and bottom by 4, you get 760/4 minus 31/4. And so that's going to equal to 729/4. And if you convert it to a mixed fraction, it's equal to 182.25 centimeters. Okay. So Paul's dad is 182.25 centimeters tall, or you can say 182.25 centimeters tall. And just write a conclusion statement that his dad is 182.25 cm tall. 182.25 works as well, so whichever you like better. Okay, so that's it for today's lesson. Please try your homework and let me know if you have any questions.